Alright, welcome to another unit. This one is on linear equations and slope. So there's kind of a lot of stuff to talk about with this one, so I've kind of organized it here for us. And so we're just going to step through it piece by piece and kind of take the pieces towards the end and do some practice problems. So we're going to start out talking about ordered pairs. Now, all ordered pairs come as x, y. And so if we have multiple ordered pairs, we need to use subnumbers. So we have this x sub 1, y sub 1. That's just in reference to this first ordered pair here. And so our x sub 1 would be 4 here, and our y sub 1 would be 3. Here is our second set of ordered pairs. And so we have x sub 2, which is our negative 5, and y sub 2, which is our 7. So this ordered pair here is our second ordered pair, so we use sub 2. If we have multiple, we would just use sub 3, sub 4, sub 5, and so on and so forth. So let's go ahead and take a look at this example, and we're going to look over here at slope. Now slope is just how steep or shallow, I guess you could say, a line is. So if we have a graph here, and we have a line coming through, we're just seeing how much it changes up to how much it changes over. That'd be a straight across. So if we look here, we see that m is always in reference to our slope, is rise over run. So we always move in the up-down direction. It's up if it's positive, down if it's negative, and then over we're either moving left or right. If it's left, then it's negative, and if it's right, then it's positive. So here we have an equation that says y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So let's take a look at that over here. So we have y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we just plug it in. We take our y sub 2 and we subtract our y sub 1, which is 3, divided by our x sub 2, negative 5, minus our x sub 1. And so we get 7 minus 3 is 4, and negative 5 minus 4 is negative 9. So we can see that the slope here is a negative 4/9. So we're going to continue on in using this here. So let's come down here. And we have this form that's called slope-intercept form. So again, you see this m, that's our slope. And it says it right in the name here, slope. And then this b here is our y-intercept. It's where it crosses our y-axis. And then this y and this x is just general points. So let's say we have an equation of y equals negative 3x plus 2. So we are going to start at our y-intercept of a positive 2. So we come over here, and on our y-axis, we make a point at 2. Now here we said that this was our slope. So m is negative 3. And since it's a whole number, we can put it over 1. And so then we have rise over run. So this says we go down 3 from our y-intercept, 1, 2, 3, and then we move in the positive direction, 1. And then if I can do this, whoa. Sorry, my lines aren't very straight. There's our line right there. Well, you get the point. And so this equation is represented by this line that's right here. All right, let's take a look. So that's slope-intercept form that we just talked about. So now let's talk about point-slope form. Now point-slope form means that you have a point and you have the slope. So let's say let's just say we have 2 points. So let's say we have 4, 2, and 5, negative 6. So we have to find this slope first, And so we're going to say, okay, here we have our x sub 1, y sub 1, x sub 2, y sub 2. So if we remember our equation, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And so we say negative 6 minus 2. Okay, here's my negative 6, here's my 2. Subtract it over 5 minus 4, which is negative 8 over 1, which is just negative 8. All right, and then we are going to come here now. We have point, which is this y sub 1 and x sub 1. We have our slope, which is m. And then this is, again, our general x and y. So we're just going to leave those as x and y. So we have y minus, let's come over here and take our y sub 1 equals, our slope is negative 8, x minus 4. Now we use just our solving equation principles, and we come here and we distribute this through. So you have y minus 2 equals negative 8x. The negative times negative is a positive, and 8 times 4 is 32. Okay, we want to solve for y. We'll actually put it in slope-intercept form, which is y equals mx plus b. It's okay, I'm going to add 2 to both sides. And so I get that y equals negative 8x plus 34. And if we wanted to graph this, you'd start at your y-intercept at 34, and then you'd have a slope of negative 8 over 1. But we're not going to do that. We'll take a look at one similar down below. So we've seen slope-intercept form, we've seen point-slope form, and the final form that we won't talk too much about is called standard form. And this says that ax plus by equals c. So you have all of your variables on one side and it equals a number. And we see that a, b, and c have to be integers. A reminder, integers are positive and negative whole numbers. And so really when you get it in standard form, you're looking for your x-intercept, so where it crosses your x-axis, and your y-intercept, where it crosses your y-axis. So let's take a look at an example. Let's say we have 5x minus 2y equals 10. So when we have our x-intercept, we know that y is equal to 0. So we're going to just plug in 0 for y, and we see that that cancels out, it's just 0, right? So now we have 5x equals 10, divide both sides by 5, and so x equals 2. So we have the point 2, 0. Let's go ahead and graph that over here. So we have our x is 2, and our y is 0. Now with our y-intercept, where it crosses our y-axis, we know that our x has to equal 0. And so we come here and we say, okay, 5 times 0 minus 2y equals 10. That's the 0. Now we divide by negative 2, divide by negative 2, y equals negative 5. So now we have the point 0, negative 5. So now let's come over here, and we have negative 5, and then we have to connect the dots. Again, sorry, my lines aren't very straight. If I was actually doing this on paper, I'd be using a straight edge. But this is a different way to solve these, or graph these equations, by finding the x and y intercepts. And that works most of the time. There's 1 or 2 times where it's not, or a few times it's not going to work. So let's take a look at a few examples. Ooh, let's get it there. All right, perfect. So here we see that we have this already in the form of y equals mx plus b, which is nice because now we can just graph it. So here we have negative 2. So I'm going to put a point at negative 2. And then my slope, which is my m, is 3. And like I said before, a whole number, you put a 3 over 1. So you go up 3, 1, 2, 3 over 1. And I'm going to cheat this time so we can make this look nice and pretty. I'm going to use my line tool. Okay. So there's my line. We'll put arrows on the ends of it. All right, cool. So that's all we have to do for that one. So this is, I'm just going to label it as A. All right, so this B, notice how we have 2 points, and we could just graph these points and then graph it, but let's make an equation. So we need this m equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. And so this is to make an equation. So we have, let's label these, x sub 1, y sub 1 is my first set, and x sub 2, y sub 2. There's my second set. So I go negative 2 minus 1 over 4 minus a negative 3. Don't skip this step because oftentimes you miss this here. So negative 2 minus 1 is a negative 3 over 4 minus a negative 3. This is the same as saying 4 plus 3, which is 7. So my slope is negative 3/7. Now we're going to use that point slope form, which said y minus y sub 1 equals m times x minus x sub 1. And so we need to just plug in. Let's use this sub 1 set here. So we have y minus 1 equals our slope, which we found to be negative 3/7, x minus a negative 3. So we can just make this plus positive. All right, so we need to distribute. Okay, so we have y minus 1 equals negative 3/7 x minus, so we have negative 3/7 times 3 over 1, so it's negative 9/7. And then we need to add 1 to both sides. And so we have y equals negative 3/7 x. This is like saying 7/7 minus 9/7 is negative 2/7. So minus 2/7. Now here's where it gets a little bit tricky. With this negative 2/7, we are going to, on our y-axis, because that's our slope our y-intercept, we're going to go down 2/7. So we're right there. And now I'm going to go down 3. 1, 2, 3. And then I'm going to go over 7. And so notice how I didn't go negative, negative. I went down negative, and then I went in the positive. Both of these are not negative, just one or the other. So now I'm going to pull out my line tool. Looks like I was close, but I missed it. That's all right. We'll just move it down. Okay. And then I'm going to add arrows to it. Make your lines long enough to see kind of how it moves a little bit. All right, let's go on to the next one. It looks like we have 3 for this side. So here we already have our slope, and we already have our x equal to 0, right? So this is our y-intercept. I don't know if you guys noticed that, but so really we already have this y equals mx plus b form. Our y equals negative 3 over 4 x plus 4. It doesn't always work out that way, but since we already have our y-intercept when x is 0, we know that we have it in this form. So we start at 4. It's negative, so we go down 3, 1, 2, 3, and then in the positive direction 4. Let's get our line tool back here. All right. And so now we add our arrows at the end, and there we go. All right, this one, notice how it's in standard form, ax plus by equals c. And when we add it in standard form, we could solve for y and get it into slope-intercept form, but let's find the x-intercepts and the y-intercept. And so with the x-intercept, we put our y equal to 0. So we have 6x plus 9 times 0 equals 18. That cancels. So 6x equals 18 divided by 6. X equals 3. So we have the point 3, 0. So let's graph that. 3, 0. And then with our y-intercept, we put our x equal to 0. And so we have 6 times 0 plus 9y equals 18. This just cancels because it's 0. We divide both sides by 9. And y equals 2. So we have 0.02. Notice how these aren't the same. You have your 0 in for your x, and in this one you had your 0 in for your y. And so we come here and we say, okay, at positive 2. Let's get our align tool. And we connect the dots, the points I should say. And we add our arrows to the end. Those almost look parallel. Not quite though. Alright, now let's take a look at this one. We could put this as ax plus by, so in standard form it actually wouldn't work because we'd get our point at 0, 0. So let's see if we can get it into slope-intercept form. So really we have this understood plus 0 here. And let's also fill in, we have an understood coefficient, the number out in front of our x, as a 1. And as a fraction, it's negative 1 over 1, so plus 0. So we start at 0. And we go down 1 over 1. And by the way, I could continue this slope on infinitely if I wanted to. I just am choosing just to go one set of them and then call it good. So let's connect the dots here. Oh, missed that one. It's all right. We'll just move it. There we go. And then every good line has arrows at the end. Okay, just a few more. These are some special examples because if we were to try and get it in slope-intercept form, you'd get this y equals 0x minus 2, which really doesn't tell us much, right? Because we have this slope of 0. So we have a y-intercept of negative 2. And what this says is no matter what our x is, okay, it doesn't matter what it is, our y will always equal negative 2. So let's just take a look at it in a t-chart. If our x was 1, we'd be at negative 2. Our x was 2, we'd be at negative 2. X was negative 5, we'd be at negative 2. So here we go, 1, we're at negative 2. 2, we're at negative 2. Negative 5, we're at negative 2. And so what you notice is you get this nice straight line here. And so it's this horizontal line that is at negative 2. So whenever you have a y equals, okay, and there's no x over here, you're always going to get a horizontal line. And so what do you think if you have an x equals with no y, you're going to get a vertical line. And in this case, we actually have a slope that's not defined because we have an infinite rise over no run. So if someone asks you what's the slope of an x equals equation, like an x equals 4, x equals 7, it's going to be undefined, just so you know. And with this y equals, your m is actually just 0. 0 and undefined are different. All right, so let's take a look at this one. X equals 4. So no matter what our y equals, our x will always equal 4. We could do a t-chart if we want of our by plugging in, but we'll just see that we get a vertical line. So I'm going to come in here, and I'm going to put this in here and finish out with my arrows. So hopefully that helped. I put a quick guide on there for you as well, so that I kind of summarized all this stuff on here. But if you need to watch this again, go for it. If you feel like you're ready to move on to the practice, then go ahead and do that as well. So enjoy your time graphing lines and working with equations.